Hi, today we will be learning about different types of mixtures. The points that will be discussed throughout the video are what is mixture and different types of mixtures, comparing between different types of mixtures, and Tyndall effect along with the practical experiment. First, what is a mixture? Mixtures are a combination of two or more substances that are physically combined but not chemically bonded. They can be classified into two main types, homogeneous and heterogeneous mixtures. We will start with the homogeneous mixture, and this is a mixture that has a uniform composition throughout, meaning their components are evenly distributed and cannot be easily separated. Also, a homogeneous mixture is known as solution that contains a solute that dissolves in a solvent like salt water or sugar in coffee. Also, another name for homogeneous mixture is alloys, which is a metal mixture with uniform composition. And next we have the heterogeneous mixture, which has a non-uniform composition where different components can be distinguished, and it has two types, suspension and colloid. Suspension is large particles that settle over time like sand in water or muddy water, and colloids are tiny particles that remain dispersed without settling like milk or fog. Here's a clear comparison between solution, suspension, and colloid in particle size, visibility, and settling. We will start with solution. It's very small, it's smaller than 1 nanometer. It's appear clear and cannot be seen by naked eyes and does not settle over time. While suspension is larger than 1000 nanometer, it's cloudy and can be seen by naked eyes. Its particles settle down over time due to gravity. Colloid is medium, range from 1 to 1000 nanometer. Its particles are not visible to the naked eyes but can scatter light. It does not settle over time. And then we head to the Tyndall effect. The Tyndall effect, also known as the Tyndall phenomena, is the scattering of a light beam by a medium containing microscopic suspended particles, for example, smoke or dust in a room, making a light beam entering a window visible. And here's a practical experiment explaining the Tyndall effect, where I add some salt and water and stir it till the salt is dissolved. And then in cup 2, I added some sand and water. And then I got light and placed it in front of both cups. As you can see, in cup 1 there is no scattering, while in cup 2 it became visible as beam due to scattering. Here are some key observations. When light is passed through a clear solution without suspended particles, there is no scattering. And when light is passed through a colloidal solution with fine particles, it becomes visible as beam due to scattering. This explains the natural phenomena like the blue color of the sky and the reddish hues of the sunrise and sunset, because blue light is scattered out of the direct path. Here are some questions you may ask regarding the Tyndall effect. First, why is Tyndall effect experiment done? It's done to determine whether a mixture is true solution or colloid. The second question is, what is the reason for the Tyndall effect? The colloidal particles first absorb energy from the incident light and then scatter a part of this energy from their surface. Thus, Tyndall effect is due to scattering of light by the colloidal particles, and colloidal particles are seen to be moving as points of light moving against the dark background. Here is some further explanation for the figure above. When a strong light beam passes through a colloidal solution, its path is visible when the light beam is viewed perpendicularly. Such a phenomenon is called the Tyndall effect. In the Tyndall effect, the colloidally suspended particles outline the path of a strong beam of light because of the scattering of light by the colloidal particles. As a result, it can be used to determine whether a given solution is a colloid, but not with certainty, as some fine suspension, also known, shows the Tyndall effect. The intensity of scattered light is affected by the density of colloidal particles and the frequency of incident light. Thank you so much for listening.